All right, we were just starting problem number 12 on page 12 of our 8.6 notes. So we were talking about the wording here, population. So whenever it says in thousands, that means you have to actually divide the number by 1,000 because this is saying they're adding 3 zeros to it. So if you take this number and divide by 1,000, what that does mathematically is move the decimal 3 places back. You can do it in your calculator and you'll see, because this is how we write it. So 147, sorry, that's my dog. 147.791 thousand. So now we have walking speed is in feet per second. And population, we already said, is in thousands. So find the walking speed of people in this city. So this is our P, because P is population. So we'd write W of 147.791, because remember, we're just plugging straight into this equation, equals 0.37 natural log of 147.791 plus 0.05. So once we get it plugged in, it's just a simple plug and chug problem, but that was the key. And I know there's one like this on the Chapter 8 test and quiz that has wording like this. So you just have to remember 1,000 has 3 zeros. So we have to move the decimal place 3 places back and then add the word 1,000 like they have. Okay, so let's go ahead and plug that into our calculator. And then I promise I'll get the snoring dog out of my office. Let's do this first. So 0.37 natural log 147.791 close. So we have that correct. Plus 0.05. And I just like to kind of skim through it and make sure everything looks good. So 0.37 natural log, and you can use your right and left arrow key to see that, 147.791. I closed my parentheses, plus 0.05. So it says round your answer to the nearest tenth. So 1.8 followed by 9 turns into 1.9. So the walking speed of people in a city with a population of 147,791, but we still have to write it like this, is approximately, slide the paper up so you guys aren't down so low, 1.9. And remember, word problems always have to be labeled, so we need to look up and see feet per second. So 1.9 feet per second. And there we have it. Find the walking speed. That's what we found. Okay, so let me remove the snoring Boston, and then I'll be right back to start the last page. Okay, come on. Go on, girl. Sorry about that. Sometimes I think she's quiet, and then the minute I start talking, she starts talking to compete with me. Okay, so number 13 on page 13. So the half-life of radioactive iodine, 131I. So this is the name of the chemical. It doesn't have any mathematical content, is 8.04 days. So half-life, 8.04 days. if 10 grams of iodine 131, so that's not important, that's just its name, remember, but we do have 10 grams, that's original amount, is initially present, that's important, because you'll see in the formula in just a second, you need to know initial amount. Then the amount of radioactive iodine still present after T days is given by, so this is the amount after T days. So the formula is 10 e to the negative 0.0862 times T. And again, T is in days. So use the model to approximate the amount of iodine 131 still present after 2 weeks. So notice the discrepancy, days, weeks. So we need to change that to 14 days. So T equals 14 days. Round to the nearest 0.1 grams. So 10 is the amount initially present. In the next class, you have to put that 10 in there. Now they're putting it in for us, but the initial amount is always right there before the exponential part. So there's no coincidence that this is 10 and that's 10. That's where the initial amount goes. So the amount after 14 days is 10 e to the negative 0.0862 times 14. So negative 0.0862 times 14. And remember, they open this parenthesis and you have to know to close it at the end. And it, because it's an E, they'll already do the caret and the open parentheses. You just have to close it at the end. So let's see how much of that 10 grams is left after 2 weeks. So just as before, you type it in just like you see it. So 10, and then you do second ln to produce your E. It gives you the caret, it gives you the parentheses, so don't forget your negative 0.0862 times 14, close. So negative 0.0862 times 14, close. Hit enter, and it says round to the nearest tenth of a gram. So 2.9 followed by a 9 means make that 10, which makes that 3.0 grams. So approximately 3.0 grams are left of the iodine 2 weeks after it began its radioactive decay. So everybody good with that? Pretty much plug and chug. Now there's one down here later that takes a lot of work, but these first ones are pretty easy. You just have to read what the variables represent. Okay, how long will it take? Okay, so this one's not so easy. I thought it was down here, but there's 2 of them that aren't so easy. So now they're telling us it's decaying to 0.5 grams. So where are we going to put that at? We know it's going to be more than 14 days, right? Because 14 days there's still 3 grams left. So isn't this the amount? And look at our formula. Isn't this the amount? So I told you right here, amount of radioactive iodine. That's this A of T. So that is where we have to put the 0.5. And that's when the problem gets a little bit harder. Why? Because then we're solving an exponential. It's not a plug and chug problem. So in place of A, and then round to the nearest tenth of a day. So in place of A, we're going to plug in 0.5 equals 10. The E stays. the negative 0.0862t stays. So now do you see why this problem's harder? It's not a plug in your calculator problem. So this is actually an exponential, and remember how we learned to solve exponentials by taking the log of both sides? But when you take the log of both sides, guess what? You have to have your exponential isolated first, and this is why a lot of people miss this. This is the last problem on the Chapter 8 test and quiz, is they don't isolate first. So this is my exponential, the base and its exponent. And as you can see in this problem, it is not isolated. So that's my first step, is to get that alone. So I have to recognize that this is times. So I have to divide both sides by 10. And I'm going to flip it around because I like having my variable on the left. So what's left is e to the negative 0.0862t equals, and now I have to type this in my calculator, or hopefully you know that when you divide by 10 it moves the decimal over, so it's going to be 0.05, but we can certainly verify it. I don't want Miss Norris to make any mistakes. So 0.5 divided by 10, boom, 0.05. Okay, so think back to the exponential problems we just did earlier on this section. The very first thing is you see the e, and that tells you to take the natural log of both sides. So I need to add natural log here, and I need to add natural log here. And it does have to be in front, and it does need to be done to both sides, and I couldn't have done it on this step because my exponential wasn't alone. So once I get the base and its exponent alone, then because it's e, I take the natural log of both sides. So now we have to think about more that we learned previously. This chapter totally builds on itself. So you miss one section or don't do one section of homework, it just keeps coming back to bite you. So everybody remember that when the base of the log, and aren't natural logs always e, right? When the base of the log and the base of the exponent are the same, they undo each other, and the answer is just the exponent. So my next step is to say, oh, well, this is gone. They undo each other. So my answer is negative 0.0862t equals natural log of 0.05. Off the page. Okay, so this was gone because they undo each other. So this comes down using the power rule, and I get negative 0.0862 equals whatever's left on the other side, which is natural log of 0.05. So it looked ugly, but it's actually a pretty easy problem. I'm only one step away from being done. To get my t alone, I do the opposite, which is divide by negative 0.0862. Whatever I do to the left, I do the same thing to the right, negative 0.0862. And like I said, this is the last question on your Chapter 8 test or quiz that we're going to have. So this is big, and we do another one down here, so you'll get a couple to practice. Okay, so t is approximately, because remember how it said round to the nearest tenth of a day. One thing you need to keep in mind is we know it's bigger than 14 days, so we can kind of see if our answer's on the right track, because 14 days, there's still 3 grams left. So let's see what we get. Natural log 0.05. Close your log. divided by negative 0.08